Alright, in this problem we once again are going to try to verify that a certain set along with a binary operation actually forms a group. In this case, we're looking at a set of rational numbers, and the operation looks like addition, only we always at the end add an extra 3. So let's see what happens. First we need to make sure we have a binary operation, meaning if we apply this operation to two rational numbers, we again get a rational number. And of course, if you add two rational numbers, it's still rational. Add the number 3, it's still rational. So we're good on the binary operation. Okay, next we need to check associativity. So this is what happens when we first apply the binary operation to two different elements, and then apply it to a third. And we want to make sure that we wouldn't get something different if we had first applied it to these elements B and C, and then applied it to A. So let's take a look at what we get. Well, let's see. The operation when you apply to A and B gives you A plus B plus 3. And then we need to apply the operation to this new rational number and C. When we do this, we have to add these two numbers. So we get A plus B plus 3 plus C. And then we always add 3 on the end. Okay, and of course it makes, I don't know, aesthetic sense or something to rearrange this. A plus B plus C plus 6. Alright, now we want to see what would happen if we had first composed the B and the C together and then did the A. So, if we first do the B and C and then do the A, what happens? Well, let's see. If we do A with B and C, we're supposed to, let's see, add A and, well, whatever B star C is, and then we have to add 3. Okay, so now all I need to know is what is this B star C, and of course that's A plus, alright, B star C is B plus C, and we still have plus 3. And, well, okay, again, we're going to be able to combine some terms here, and we get A plus B plus C plus 6, which is precisely what we got in the first case. Alright, so associativity checks out. Okay, next comes the identity element. So for the identity element, what do we need? We need to find some element that when we apply it to A, say, we'll get back A. So, okay, let's take a peek. Now, there's two good ways of finding the identity element if it exists. One is make a good guess and check to see if it works. The other is figure out, well, if the identity element exists, what does it have to look like? So we're going to take the second route here. I'm going to say, okay, if I had some identity element, call it E, say, then when I apply it to A here, I should get back A. On the other hand, by definition, this is going to be A plus E plus 3. Okay, so on the one hand, I should get A. On the other hand, I get A plus E plus 3. Well, the only way that can happen is if E plus 3 is 0. And of course, E plus 3 is going to be 0 precisely when E is equal to negative 3. So if we have an identity element, that's what it's got to be. And of course, reasoning backward, it must be the identity element because we took A arbitrarily. If we add A to negative 3, or we compose it with negative 3, A times negative 3, we're always going to get A plus negative 3 plus 3, which is equal to A. So negative 3 really is our identity element. Okay, last we need to find inverses. So in this case, we need to find something that we can compose with A and get back to the identity, which is negative 3. Okay, again, we could guess at what it is, or we could just suss out what it must be if it exists. So, if we had A star B and it equals negative 3, what does that mean? Well, A star B is A plus B plus 3. And so what does this imply? If A plus B plus 3 is equal to negative 3, then, let's see, A should equal negative 3 minus B, which is equal to negative 6 minus B. So A better be negative 6 minus B. Of course, I want what B is, so let me switch these up. So this would mean B is equal to negative 6 minus A. So my inverse element is going to be negative 6 minus A. And let's double check. If I do A times negative 6 minus a. This gives me a plus negative 6 minus a plus 3. And well, let's see, we get a and negative a, that's 0. Negative 6 plus 3, that's negative 3. So in fact, our inverse element is always going to be negative 6 minus our original element. All right, there's a little technicality you want to check. Inverses are supposed to work on both sides. Okay, but the commutativity of addition is going to make it so that it doesn't matter which side we work on here. So we get inverses, and consequently, we have a group.